last semester you studied anatomy, and anatomy, as you know, is the study of structure. So that is, what is this tissue type? Name this bone, name this part of the bone, name the parts of the nerve, name the different parts of the heart, and so forth. Okay, so that's going to be the study of structure. This semester we are looking at the physiology, or the study of function, or in other words, how does that structure work? Okay, and then once you get through this semester, then you will potentially go into looking at pathology or pathophysiology, and that's basically the study of disease, or what happens when the structure doesn't function properly, and then that leads into a disease process. Okay, so you really have to understand how things work normally in order to understand what's occurring when something is not working normally on this. Now, there are a few very important overriding mechanisms that you really have to know early on. Okay, and I don't want to underestimate or underemphasize this because this is so important. Now, as we go through the semester, we may not be specifically talking about these things, but these concepts have to be in the forefront of your mind, thinking, okay, what is going on and why are these processes occurring? So now that's very nebulous sounding. Let's go into the first concept that we're looking at. And the first concept that we're looking at is homeostasis. Now, you may have talked about that in anatomy. I'm not sure who the individual instructor that you had. So some of this may be redundant on you. Okay, so it'd be a good review. So the first concept we're looking at is homeostasis. Now, homeostasis is the ability of your body, the ability of an organism to maintain a relative stability or a consistent internal environment when the environment around it changes. Okay, so that's kind of an odd way of saying it, but homeostasis is your body wanting or has the ability to maintain relative stability. Okay, so let's use an example on this. We're in the wintertime right now, and outside is cold. All right, so when you're in the house, you have your thermostat in the house set at, say, 70 degrees. Okay, when the internal environment of the house, when the temperature drops below 70 degrees, your furnace kicks on, heats up the house, and when your house warms back up to its set temperature, 70 degrees, the furnace stops and the temperature is maintained. So over time, that temperature is going to drop down again. Furnace kicks on, warms that temperature up. Okay, that is a homeostatic mechanism for your house. All right, and that's for the temperature of your house. Well, your house, my house, our body. Okay, and so we have a mechanism in our body that maintains body temperature. Now, everything in our body is going to somehow be associated with this homeostatic mechanism. And for the most part, we want to maintain a consistent relative internal stability in an environment when everything's changing on the outside. So now what does that mean? The temperature outside right now is going down. Our body adapts to it. Okay? And if we're in the summer, the temperature rises, the external environment is changing, so that's a variable, and our body will adapt to that change. So if it's hot in the summer, we can sweat, and that helps to bring our body temperature down. So those are a couple of the mechanisms that we are going to look at. So let's look at, let me get this thing on. Let's look at the various components of the homeostatic mechanism or the control. There's three primary components. There's going to be a receptor, there's going to be a control center, and then there's an effector, okay? All right, so the first one, let's look at this. This is the stimulus. So that's stimulus, okay? This would be consistent to the temperature in the room, okay? If the temperature rises or falls, that's the stimulus that you are feeling. So that's the first kind of component on this one. But that stimulus stimulates a receptor, okay? So this is going to be a receptor. So this is your first real component in the body. The stimulus is just a changing environment of some kind, but it has to affect, it has to stimulate a receptor, typically a nerve, okay? So we have receptors in our skin. So if it's cold outside, we have temperature receptors that you learned about last semester that is sensitive to temperature, so heat or cold. That external environment, if it gets hot, will stimulate that receptor. It sends an afferent, and you haven't had me before, so afferent and efferent. I'm intentionally mispronouncing those words, primarily because if I speak very fast, afferent and efferent and stuff like that, they sound alike. So afferent, let me just write this, A-F-F-E-R-E-N-T, and this is going to be E-F-F-E-R-E-N-T. So you probably remember that from your nervous system last semester. So in this case, we are stimulating a receptor. It sends an afferent signal. It sends a signal to the control center. And if this is your nervous system, let's say your body temperature, this will be your hypothalamus in your brain. Not way back there. It's kind of right in here. So the hypothalamus, if you recall from the skeletal system, the skull bones, if you remember the sphenoid bone, and if you remember the sella turcica, that's where the pituitary gland sits in there, kind of superior to the pituitary gland, that's going to be the hypothalamus. Okay, so that's kind of right back in here. And that's the control center for body temperature. So the control center would be the thermostat on your wall, okay? And the thermostat says, okay, we have it set at 70 degrees. In your body, 98.6, okay? So our thermostat says we want our internal environment to be 98.6 degrees. And if it deviates from that in any measurable amounts, then your body is going to adapt to that change in temperature and correct it, okay? So if your body temperature drops down, so 98.6 to 98.5 to 98.4, okay, so our body's getting colder, the mechanism is to send out an efferent signal to an effector. Okay, so that is what it has an effect on, okay? So again, if we're talking about body temperature, the receptor is the nerve endings that's recording temperature. It goes to the hypothalamus and it says it's cold, it's hot, whatever that situation is. So if it's cold, the control center then sends a signal to the skeletal muscles, okay? And the skeletal muscles will contract. So if you go outside right now in the wintertime without a jacket, what's the first thing that you are going to start noticing? You might get goosebumps, okay? The erector pili muscle from the integumentary system, all right? I'm always going to go back to some things from last semester. Those will contract. That's usually the first thing. The first thing is you are sensing the temperature is cold. That sense then sends a signal or stimulates a receptor, sends a signal to the control center. The control center says, ooh, I'm getting cold, temperature's going down. It sends an efferent signal to an effector, erector pili muscles, to give you goosebumps. Now, why goosebumps, okay? Well, muscles are just an engine. That's all they are. And if you start your car motor, and let it run for a couple seconds and then turn it off and put your hand on the engine, you would notice that the engine is warm. Same thing for the muscles. Muscles generate heat, okay? The intention is muscle contraction, but that is a motor. It's going to generate heat. When it generates heat, your body temperature is going to increase. So let's say the goosebumps don't correct the situation. Next thing that happens, you start shivering. You are bringing in, you're incorporating more skeletal muscles to do the shivering, which are muscle contractions. The more muscle contractions you have, the more heat is generated. When you have more heat generated, your body temperature goes up on this one. So this last one is homeostasis restored. Okay, so that's your body temperature. Now, the mechanism that we just talked about here is just for body temperature, but everything in your body basically focuses on one of this. This is the first concept that we're going to look at. Next thing we're going to be talking about diffusion and active transport and membrane potentials and all of that fun stuff. But these are your basic components. So when we're looking at this, there's two mechanisms of homeostasis that's typically controlled or controls homeostasis. The most common one is going to be what's called negative feedback. So again, when we're looking at negative feedback on here, or the mechanism that, let me restate that. The mechanism that controls is going to be one of two different things. Whether it wants to maintain your body within a normal range or whether it deviates from a normal range. So the image that we see here, let's just set let's just say this set point here is let's say this is 98.6. Okay, so this is what we're looking at on this one. And if your body temperature warms up, so let's say this is 99 degrees, it will do whatever is necessary to reverse that issue, okay? And let's say you sweat. That cools your body temperature down, okay? So now we're down to 98.4, let's say. Now you're cold. Your body temperature does muscle contraction to warm you back up. But it's this line, it's the line in here. That is your set normal temperature on what you want to maintain. Now, most of the body is regulated by this negative feedback mechanism. And negative feedback is based, wrong one. I'm just moving. I've got three monitors in front of me. So when I look around, I've got a couple things that I'm just trying to visualize here. So when we're looking at the negative feedback maintains this variable with an opposite stimulation. So what's that mean? The variable is temperature. In this case, we rose up to 99 degrees. The opposite of that is going to lower it down. Now, if you're cold, the opposite is going to keep up. But it maintains within that normal range. That's negative feedback, okay? Now, when we look at positive feedback, and I don't think I have a picture on this one. Positive feedback basically increases the original stimulus. Now, there's only a few mechanisms in your body that is associated with positive feedback. And throughout the semester, we'll talk about those. But if you're ever on a test and you just draw a complete blank, go with negative and memorize the 3 or 4 different positive feedback loops on this one. So let's look at what positive feedback would be. The easiest one to think of is labor. Okay, so if you're pregnant and you start labor and you start the contractions, that's an example of positive feedback. And what happens there is the baby's head, getting ready to deliver it, the baby's head pushes up against the cervix. The receptor, that's the stimulus, the receptors are the nerve endings in the cervix, sends a signal to your brain and says, hey, something's pressing on the cervix. It releases, your pituitary gland will release oxytocin. Oxytocin is a hormone that goes to the uterus that tells it to contract some more. When the uterus contracts more, it increases the pressure on the cervix. If you're contracting on the outside and it's pushing the baby's head against the cervix, you are increasing that stimulus, sends a signal back to the brain, says, hey, something's pressing on the cervix, release oxytocin, which then causes the uterus to contract any more, which causes more stimulus at the uterus, more pressure, and that's a loop. So that one is increasing the signal of movement away from that normal. Normal would be no contraction, but we're increasing that signal, okay? So labor would be one, and associated with labor, breastfeeding is another. So as the baby suckles, the stimulation of the nerve endings on the breast sends a signal to release oxytocin from the brain. Oxytocin goes to the breast tissue to release milk. Baby feeds, and as long as the baby's feeding, the suckling continues until the baby's full. That stimulation stops, oxytocin stops being released, and the release of milk stops, okay? So that's another one. There's blood clotting. So those are three big ones that we're going to look at as we go through this semester. So those are that. So, here's the thing. So the left picture is dealing with the negative feedback, and the right picture, this is dealing with the positive feedback. So you can see that the event accentuates this one, and it does not maintain a normal balance on this one, okay? So you'll figure this one out. That comes together. That is the basic of homeostasis. Next thing up, we're going to look at more of Chapter 2. We're going to look at different things on chemical bonds. Not a chemistry class, so don't freak out. I wasn't a chemistry major myself. But we're going to look at chemical bonds and how they are relevant to everything else that we're going to be looking at. So, until then, catch you on the flip side.